Hi everyone. In this video, we are going to look at the proportions. We have 4 learning objectives. So basically, we want to be able to identify a proportion or verify a proportion, right? Then we are going to solve a unknown variable if we are given a proportion. And finally, we are going to solve some application problems in similar figures using proportion. So let's do this one by one. First, what is a proportion? First of all, proportion has this format. It's like one fraction on one side, the other fraction on the other side, and they are equal. Apparently, denominators b and d cannot be 0. I like to emphasize that a, b, c, d here, they don't necessarily mean single numbers, and they could be expressions. Each of them could be an expression. It's just a structure. Now, how do we identify or verify we have a true proportion? Actually, it's very easy to do. Since the requirement to be a proportion is that 2 fractions are equal, right? You have 2 different ways to do that. One way is using this one as an example. You can reduce one fraction to see if they are equal or not. Say if I look at the second fraction on the right-hand side, I can reduce it by dividing both numbers by 2, right? Because both are even numbers. So 10 divided by 2 is 5. 16 divided by 2 is 8. So these two are equal. So by definition, this is a proportion because proportion means 2 ratios or 2 rates, which are fractions, by the way, are equal. So we have a proportion. And this is one way to do that. There's another way to do that. That is, you do cross multiplication. If the cross multiplication, the products of those cross multiplications are equal, then it is a true proportion. For example, 1 cross is 5 cross multiplication, right? 1 cross is 5 times 16, and the other one is 10 times 8. We just need to ask us if they're equal or not. This is the 80, this is the 80. They are equal, so this is a proportion. So this is a kind of property. If 2 ratios are proportional, then their cross products are equal. We just did that. So you can use this property to identify if a proportion is true or not. Now let's look at our first example, determine whether the ratios are proportional. So we have 2 examples, and let's look at those one by one. So we just go ahead and do the cross multiplication. That's the easiest way to do than simplifying fractions with decimals in it, right? So we do cross multiplication, 3.5 times 3.2, that's on one side. The other side is 1.4 times 8. Now let's use the calculator. Let's see. 3.5 times 3.2. I get 11.2 on one side. The other side is 1.4 times 8, 11.2. So they are equal, cross product equal. The answer is yes. So this is a proportion. So very straightforward, very easy to do. Now, second one, same question, is this a proportion? We do cross multiplication again. And certainly you can do division on each side using fractions to see if they give you the same result. Same result means both sides are equal, right? So that's one way to do it, but you can also do cross multiplication. Let's do cross multiplication. 3/4 times 1/2, that's one side, one cross product. The other one is 5/12 times 3/10. Now, When we multiply fractions, usually we simplify them first. This one cannot be simplified. 3 and 2 cannot be simplified. 3 and 4 cannot be simplified. So we just horizontally multiply them out. I get 3 over 8. That's one side. The other side, certainly we can simplify between these two. Divide by 5, we get 1. Divide by 5, we get 2. Now what do we get? We get 3 on the top, 24 on the bottom. 12 times 2 is 24. Apparently, these two are not going to be equal because numerators are already equal. If these two fractions are equal, denominators have to be equal too. Apparently, they are not equal. So answer is no. It's not a proportion. You can even do cross multiplication to see if they are equal or not. Let's look at another objective. Solve an unknown variable, unknown value in a proportion. So in other words, we are given proportion, we assume this is a true proportion, which means the cross multiplication product will be equal. So we are going to use that property to solve proportions for an unknown. So 5 times 8 will be equals to 12 times x. So this is 40 equals 12x. We all know what to do to solve this simple equation, right? We divide by the number in front of x to cancel it. 12 divided by 12 is 1. 1x is x. So all we need is simplify this. Our answer is going to be a fraction. So I notice that both sides can be divided by 4 at least. 40 divided by 4 is 10. 12 divided by 4 is 3. So 10 over 3. That's our final answer. If it is required that your final answer to be in mixed number format, you just go ahead and convert this improper fraction to a mixed number. Now another one, same question, solve the unknown variable in a proportion. So this is or unknown variable. This is still a proportion. We have 4 parts, 4 fractions on each side, right? Now cross multiplication, 2¼ times b equals -9 times 8. So apparently this is a mixed number, and this is going to be -72. We're going to convert a mixed number to the improper fraction when we do multiplication or division using fractions. So this is going to be multiply this two, add to the numerator, that's 9 over 4 times b equals -72. Now, in order to get rid of this one, we can just divide by this fraction on both sides, or we can multiply the reciprocal of this fraction. That's how we cancel a fraction quickly. Reciprocal just switches two numbers. So I multiply 4 over 9 on both sides. I have to do the same thing. Now you see canceled, 9 and 9 canceled, 4 and 4 canceled, get b. So here, when we multiply with fractions, we always try to simplify them first. This is the numerator because we can always put 1, imagine a 1 on the bottom. So these two both can be divided by 9. 9 divided by 9 is 1, 72 divided by 9 is 8. Now we have 1 on the bottom, we have 8 times 4, 32 on the top. Anything divided by 1 won't change anything, so the answer is -32. Don't forget negative sign. So -32. Now let's look at how we solve application problem using a proportion. So basically, if you look at this procedure here, it says you need to translate a proportion problem, application problem, the information in the description into a proportion. But how do you know it's going to be a proportion problem it's going to be a proportion problem in the first place, right? If it is not a proportion problem and you try to write a proportion out of it, that means you're wrong from the very beginning. You don't need to do any calculation. That is wrong already. So the more important question before we do translation is that how do we identify this is a proportion application problem? Actually, it's pretty easy to do. As long as you have a fixed rate. Fixed rate or fixed ratio, then you have a proportion problem. Then you can go ahead and do translation. Now let's look at an example to see how we translate a description into a proportion setup. Example 4, a Bobby can read 40 pages in 50 minutes. This is just a basic description. This is a fact. At this rate, now here's the most important information in this whole thing, not this number. This number, a random number. Different people can read a book at different speeds. So this is random numbers, but this one gives us a proportion, fixed rate. Every 50 minutes, she will be able to read 40 pages. This rate never change, at least for this particular problem. So this is a proportion problem. The question is, how long will it take her to read 220 pages? Now we don't need to worry about answers. We just need to be able to set up a correct proportion and being able to solve it, and we will get the answer. So answer itself is not a problem. So now we know it is proportion, how to set it up. See, I have two different ways to set it up. It's very easy to do. Just do this fixed rate. You can write this fixed rate in two manners, two ways. One is horizontally, one is vertically. Either way is okay. That's why I have two methods, and you get the same result. So if I write this vertically, 40 pages versus 50 minutes. You don't need to write this units as long as you know 40 is time and 50, 40 is pages and 50 is minutes. That's good enough. Then equals, the other side, all you need to do is to match the meaning, match the structure of the left-hand side. The structure is that you have pages on the top, minutes on the bottom. Do the same thing. Pages on the top, this is pages. Pages on the top, minutes on the bottom. We are solving for minutes. We don't know. That's our X. So we can set up. Now I'm going to do second setup before we do the calculation. This time I write this ratio in a horizontal manner. So 40, 50. Now the other side on the bottom, since the horizontally there's nothing on the bottom yet, we put the other pair on the bottom. All you need to do is match the same structure again. Left-hand side pages, right-hand side minutes, left-hand side pages, right-hand side minutes. See that? Either way is okay. Now let's solve it. Cross multiplication. 40x equals 50 times 220. And to solve x, we divide by 40 on both sides. So this is canceled. Let's do the calculation. 50, turn it on, 50 times 220 divided by 40. And she will need 275 minutes to finish a book with 200 pages, 20 pages in it. Now let's do cross multiplication. 40x equals 220 times 50. We divide by 40 on both sides. Look at this. They're exactly the same. The 275 minutes. That's how you set a proportion. After you identify you have a proportion problem. Now let's look at our last objective for today for this video. So in this under this topic, we are going to solve an unknown in similar figures, like similar triangles, similar rectangles, similar trapezoidals. Now we want to know the definition, what is called similar figures. So basically it says these are those figures with the same shape and congruent corresponding angles. It's not just congruent angles, has to be corresponding angles. And proportional side length. If this is true, you have proportional figures. Now this is the one demonstration just to illustrate that definition. If we look at these two triangles, they are in the same shape. But same shape is not that very strict way to identify similar figures because human eyes are not that perfect. If they are tiny bit different in shape, nobody can detect them actually. So how do we tell if they are in the exact same shape? We look at angles. If these angles measurement, I'm not talking about the look like equal, okay, measurement. If these two are equal, for example, both are 40 degrees, and these two are both 90 degrees because perpendicular angle means 90 degrees. If you have two pairs of angles in two triangles that are equal to each other, you have similar triangle. The shape will be the same because the third pair will be automatically equal if you already have two pairs of angles that are equal, because the third angle equals 100 degrees minus the other two. 100 degrees minus the other two to get this. Since the other two are equal, sure, third one will be equal too. Why we look for two angles, two pairs of angles being equal? Because angle determines the shape. This angle, what's this angle? They give you different shapes. So angles determine the shape. That's why we look for angles to be equal. Once you have similar figures, not just a triangle, any figure, once you have similar figures, the corresponding sides will form proportions. Corresponding sides means this, the sides corresponding to equal angles. If these two angles equal, then this side measures 3 inches long and this side measures 6 inches long are called corresponding sides because they're corresponding to this equal angles. Now let's look at an example to see how we use this, how to set a proportion to solve an unknown side in a similar figures, in similar figures. So this one says find the unknown length in the similar triangles. So this is our unknown. It's solve for this. First, we are told they are similar, so we don't worry about if they are similar or not. If they are similar, we can set a proportion. Now let's set a proportion. Corresponding angles. First of all, this has to be in our setup because we're solving for B, and this side facing this angle. Or you can see this angle facing this side, either way. So this is the corresponding angle. These two angles are equal. So this two is a pair. You put this pair either horizontally or vertically. We mentioned that before using the other example, it doesn't make a difference in terms of answer. So if I put them vertically, I can use 21 over B. Now I just need another fraction. The way to set up the other one, the key part is that you have to match the structure on the other side. The structure for this particular example is that I put the number from the smaller triangle on the top, and the other side is from a bigger triangle. We need to do the same thing. In other words, the number on the top has to be from here for the one on the right side. So we need another pair of numbers. You can only have one unknown in the setup to be solvable. So we're looking for two numbers, one from each triangle. So which one do we use? It doesn't matter as long as they are corresponding sides. So apparently this two angles are equal. So this two is another pair. You can use this two as a third pair, as the one on the right-hand side. You will get the same answer. You can try it yourself. So 18 over 24. Now you just need to solve it. You can do cross multiplication. You can do something actually more efficient before you do cross multiplication. everybody wants to work with smaller numbers if that is a possible, right? Possibility, right? So you can simplify this one side first. So I can divide by 6, I get 2, I get 3. Divide by 6, I get 4. Now we can do cross multiplication. It's much easier. So 3 times b equals 4 times 21. Now we divide by 3 on both sides. Cancelled. 21 divided by 3 is 7. 4 times 7, that's 28. So we don't even need a calculator. Yeah, we solve it. Now, the last example, find the unknown length in the similar figures. We just have different figures. This time we have a trapezoid, a pair of trapezoid. Now we are told they are similar, so we just need to set a proportion. Apparently C is our unknown. C has to be in the setup, and this two is a pair because both are a longer base here. This is a shorter base, shorter base. So 12.5 over C, that's one setup. Now the other one, we just need to have another pair. Doesn't matter which pair, as long as we're solving for C, B, A, all of them. So if we solve for C, we just need to have another pair of numbers. The way I set it up on the left-hand side is that I use the number from bigger trapezoid first on the top. So this one has to be from the bigger trapezoid. So I can use this one because only number the other trapezoid that is given is this one. So we have to use this pair, in other words. There's no other numbers given. 7 over 4.2. Now let's do cross multiplication. 7c equals 12.5 times 4.2. Now c equals 12.5 times 4.2 divided by 7. So let's do the calculation. 12.5 times 4.2 divided by 7. 7.5. And they're all in inches. So we get first line. How about the B? We don't need to solve for B. You know why? Because it's a trapezoid. Trapezoid is that you have four-sided figure, one pair of opposite sides are parallel, and that's all required. The other side, they don't have to be parallel. They don't have to be unparalleled either. That means we don't care, can be anything. They don't have to be equal either. So this case, they happen to be equal. Since these two have the same shape, this one will be equal to 4.2. So we don't need to solve for B. Now let's look at A. Now for setup A, we have to have A in the setup. So this 10 is A. This is the shorter side in the parallel basis, right? So 10 over A, the other side will still use this pair because this pair are given. Since we already solved for C, you can use this pair, 12.5 over C over 7.5. That's not wrong, but usually we avoid doing that. The reason is you could be wrong when you calculate when you solve the first one. If this is the wrong answer, you use the wrong answer to do the next one, guaranteed you're going to be wrong again. So in other words, the general approach is that we use original numbers. So let's use a 7 over 4.2 again. So cross multiplication, 7a equals 10 times 4.2. This is 42. 42 divided by 7 is a 6. But let's use a calculator to be on the safe side. Ten times 4.2 divided by 7 equals 6. 6 inches. Now we've solved them all. A equals 6 inches. B equals 4.2 inches. And C equals 7.5 inches. So usually when you have application problem, you have to put your answers together. You don't want them scattered around in your inside that page, right? On that page, different places. Okay, that's all for this video. See you in the next one.